Okay, I'll just continue from here. Okay.
Lol.
Sorry about that. Yeah, so let me know if you need me to repeat. Okay, and if not, I just continue. Okay, so this is equation 3 and 4. What do you notice after I multiply by -2? Here got minus 12b, here got positive 12b. I can add them together.
Okay.
Plus 4. What happens? 6a minus 12b, 12b minus 8a, 12b cancel off, left with 6a plus negative 8a, which is a negative 2a on the left-hand side. And this one, the right-hand side, I'll just add them manually. I'll just write it out step by step. Okay, add them like this. Simplify. A square minus 3b square plus 2a square minus 6b square. I'll get 3a square minus 9b square equals to minus 2a. Wow, that is still quite difficult to solve. Let me think. Oh, this is difficult. This is difficult. Oh my goodness. I'm thinking of something very, very, very crazy. Here's how I could continue this. I want to solve for a, solve for b, right? So 3a square, I can bring the minus 2a over. So I get 3a square plus 2a minus 9b square equals to 0. Isn't this just a quadratic equation in terms of a? This minus 9b square, you just pretend it's a constant. Right? 3a square plus 2a plus k equals 0. How to solve for a? Quadratic equation. A equals to negative b. Oops, sorry, positive 2. Negative b plus minus square root of b square minus 4a. C in this case is negative 9b square. All over 2a. That's my a. That's very horrible. I still need to make b the subject. Oh my goodness. That's a bit too difficult. I am stuck. Okay, I'm gonna leave you on a cliffhanger here. And I can't, because I don't know how to continue this. This is a bit too difficult. I don't have enough information to solve for B if I continue in this path. Okay? Cut. I'll get back to you if I can find a solution to this one. If not, I'm just gonna give up on this method one. Okay? But you can solve this two equations simultaneously. It's just that it's a little bit difficult. Yeah, very difficult. Okay, I'm gonna leave it first. Then what I'm gonna do is I'll do method 2. So method 2, what we do here will simply be to method 2. This is question 3. Still on question 3. We're trying to solve for a and b. Method 2 here, what we can do is to multiply by the a plus b root 3 over to the other side. So 1 minus square root 3 multiplied by a plus b root 3. Then you expand 1 times a, 1 times b root 3, b root 3. Minus root 3 times a, minus a root 3. Minus root 3 times b, positive b times root 3 root 3, which is just a normal 3. Simplify, you get a plus 3b plus square root 3 times of b minus a. Is that okay? Okay, then on left hand side is still 6 plus 4 root 3. I think now it's easier, right? You can see what is equal to what? 6 is equals to a plus 3b. And
4 equals to b minus a.
A lot easier, right?
Yeah.
Let's try. Actually, here, since it's just linear equation, what we can do is we can use calculator. A plus 3b equal to 6, write it neatly. The other equation 2, I can write it as we write it as minus a plus 1b, this one is 1a, equals to 4. Then just key inside the calculator, you solve. I'll get a equals to, let me just use my calculator. I could solve it manually, but why do that when you have a calculator? Do you want me to show you how to solve it manually?
What do you mean?
Like solve the simultaneous equations?
No need.
Don't need, okay. Okay, then you'll get these as your two answers. Okay? Okay, now? All right, method 2 is way easier. Method 1 is a bit crazy. It is possible, but I'm not gonna do it. I can't do it in the time span here. It'll take too much time. Hey, the answer is wrong. They gave me a -9 and -5. Did I do something wrongly? Let me double check. 6 plus 4 root 3 over a plus b root 3 equals 1 minus square root 3. Is there anything wrong? Did I do wrongly? I noticed my mistake now. Here. What should it be? It should be a minus, right?
Minus 3b.
Oh, wait. No. Correct? Yeah, it should be a minus. I wrote down plus just now. Sorry. This one is wrong. Should be a minus. Yeah. Okay, let me simplify this. A minus 3b. Minus 3b, minus 3b. Is it better? Do I get my... -9 and -5. Yeah, should be correct now. Okay? Is that okay? Okay, good. Okay, question 3 done. Next question. Okay, question 4 I skip. All those that I choose to skip, they are all the same type of question. Once you're able to solve one, you're able to solve them all. Later, then I do. Question 5, let's go. Express whatever in the form of a plus b over a plus b times root 6. Okay, first thing you need to know is 96 is a very big number, so we can probably prime factorize it, right? Let's see, what will we get? Let me try. I think it's 2 power 5 times 3. Is it correct? Prime factor form. Yes? No? 5. Mic test, can you hear me?
Yeah.
Is it correct? Check with our calculator.
Yeah.
Yes, okay, good. So how do you simplify the square root of 96, right? Over here, we got square root 96. We should try and simplify it first. So square root 96, what would it be equal to? Here, what we want to do is to extract out the biggest possible perfect square we can. And here it will be 2 to the power of 4, right? Then times 2 times 3. So I hope you remember the rule. Square root AB is equal to what?
Square root A, square root B.
Multiplied. Okay, so same thing over here. You can square root the 2 power 4 times square root of 2 times 3, which is just a 6. Then what's square root 2 power 4?
2 to the power of 2.
Yes, just times half, so it's 2 power 2. So you simplify as 4. Okay, 4 root 6. Yeah, that's your final answer already, 4 root 6. Okay. Of course, if you are faster, you can immediately see, oh, square root 96. Isn't that just 16 multiplied by 6? Then you can straight away square root both sides. Then you get 4 root 6. Okay, but that requires you to know 6 times 16 is 96, which most people cannot do. Okay.
Okay.
Okay, yeah, 4 root 6. Okay, with that in mind, we can continue with the question. So copy the question first. We can replace the denominator square root 96 with what we just found. So it will be copy the whole thing, replace the denominator with 4 root 6. But we can go a bit faster. We can just rationalize the denominator as well. So here we will multiply top and bottom by, what is it? Can you tell me?
Conjugate
What is it?
this, but minus.
Correct. So square root 2 minus 2 root 3. Is it a 1 on top?
No,
What should it be?
this
The
thing.
same thing. The same thing, exactly. Okay, good. So we now simplify it. What do we get? Denominator. 2 square.
2
Minus
minus.
away. Bracket 2 root 3. Bracket square. Okay. Okay, then now we multiply. 2 root 2 times root 2. What do we get?
2.
Wrong.
4.
4, correct. Because root 2 times root 2 gives you a 2. 2 times 2 is 4. Next one, 2 root 2 times negative 2 root 3.
Minus 4 square root 6.
Yes. Good. Next one, minus root 3 times root 2.
Minus root 6.
Minus root 3 times minus 2 root 3.
2 root 9. Wait, actually 6. Okay.
Yeah, root 3 times root 3 is 3. 3 times 2 is 6. But with a positive sign. Right? Because minus times minus gives you a plus. So plus 6. Okay. Then plus 6 over 4. Anything to cancel? Yes, 6 and 4. What do you get? 3, 2. 3 over 2 root 6. Then the denominator, root 2 square is 2. 2 root 3 square is 2 square root 3 square, which is 4 times 3, which is 12. Okay, so 2 minus 12 simplifies to negative 10. Correct? You can actually just use a calculator for this. Or negative 10. Is that okay?
Okay.
Denominator? Okay, then simplify numerator. 4 plus 6, 10. Minus 4 root 6 minus 1 root 6. Minus 5 root 6. Sorry. Plus 3 over 2 root 6. Sorry. Yeah, then we can simplify this as 10 over negative 10 plus negative 5 root 6 over negative 10 plus 3 over 2 root 6. Correct? Okay, simplify 10 over negative 10, negative 1. Plus negative 5 over negative 10, positive half times the root 6. Add on, remember the question. Look back at the question. What did they ask for? A plus B times root 6. Yes, correct. Hey, wait a minute. No, the root 6 times root 6 give you a 6. 6 times 2 is?
12.
Then there's a 3 on top. You can cancel off. Okay, I write down first. Maybe I'll write it at the side to save some space. This guy is equal to 3 root 6 divided by 2 times 6, which is 3 root 6 over 12. 3, 12 cancel, 1, 4. So 1 times root 6 is root 6 over 4. Okay? Is this okay so far? Root 6 over 4, okay? Can move on. Then root 6 over 4, actually, we can rewrite it in another way, which is 1/4 of root 6. So now you got root 6 is like an apple. Root 6 is like an apple. You got half an apple, you plus 1/4 of an apple. How many apples? Use a calculator if you cannot add the fraction. Half plus 1/4.
Half plus 1/4. 3/4.
3/4. So 3/4 of an apple, in this case is root 6. And add on the -1. So therefore, A equals -1, B equals 3/4. Can?
Okay.
Okay, good. Next one. Question 5 done. Question 9. Let's take a look at question 9. Okay, question 9. You have, without the use of a calculator, simplify this guy. Okay, we need square root 10 minus square root 3 as an answer. Okay, let's do that. So the procedure is simple. You just rationalize the denominator.
Okay.
Rationalize the denominator. It's the same thing. You have to do it 2 times. So let's do that. Maybe, wait, let me copy this. I leave a blank space.
Okay.
Multiply by?
Conjugate.
Yes, correct. And the other guy, what would it be?
Conjugate.
So what is the conjugate?
Square root 3 plus square root 5. Square root 3 plus square root 5.
Must appear both times. Okay, so then yeah, it's just long-winded. It's not difficult. Then this one will just be what? 3 minus 5, right?
Yeah.
Root 3 square, root 5 square, then minus a square minus b square. Same thing for the other guy. It's also 3 minus 5. Correct?
Yeah.
Okay, then denominator done. Look at the numerator. 1 plus root 2 times root 3 minus 5. 1 times root 3, root 3. 1 times 1 times negative root 5, negative root 5. Plus root 2 times root 3, root 6. Plus root 2 times negative root 5, negative root 10. Okay so far?
Yep.
Next one, we do 1 times root 3, root 3. 1 times root 5, root 5. Minus root 2 times minus positive root 3, so negative root 6. Negative root 2 times positive root 5. Negative root 2 times 5, 10. Clear so far? Okay, combine everything together. Single denominator equals to -2. Numerator, you can add them all together. Is this okay? Add them all together. Anything to cancel?
Yeah.
Yes.
Root 5 can cancel root 6.
That's it. Okay, then we get 2 root 3, 2 copies of root 3, and minus 2 copies of root 10 over -2. Here, another way that we can simplify this is factor out a -2. Then we'll get negative root 3, positive root 10, all over -2. After you factorize, there's a factor multiplied by another factor. You can cancel off common factor. Okay, common factor of -2. Here, there's a -2 times 1. So cancelling off the -2, you're left with whatever that's left over 1. Divide by 1, don't do anything at all. So it's just the numerator. Just the numerator. Which is, if you rewrite it, it's root 10 minus root 3. When I say root, I mean square root. I'm just being lazy. Yeah. Okay, so that's the answer. Root 10 minus root 3. Can? Any questions?
No.
Okay, moving on. Yeah, let me rearrange. Okay, next one. Question 11, then 12. Did I go through 12 already? Oh, no. I just gave a clue only. Okay, let's just do it. Okay, let's take a look at question 11. You got simplify whatever without the use of a calculator. Okay, this is just a surds question. I mean, exponents question, which involves a little bit of surds. Here you got 1 over 2 minus square root 11 divided by square root, divide by bracket first, square root 396 over 9 minus square root the whole thing, 11 over 9. 396 is a bit big. Can we simplify the square root 396 first?
Okay.
What would it be?
I have no idea.
Okay, prime factorize it for me first.
Okay, is 2 square times 3 square times 11.
Very good. So that means what's the biggest perfect square here?
Biggest perfect square.
Yes.
Uh, um,
Yeah, exactly. Yes. Oh, and therefore it's yes, correct.
okay.
Whenever you got even powers, then it will be a perfect square because perfect square just means that when you square root, which is power half, you multiply an even number by half, you just cancel off the factor of 2, and you're left with a positive whole number integer after you divide by 2, after you multiply by the half. Then if it's still a whole number power, then it will become a perfect square. So in this case, yeah, 6 root 11. Okay, so we'll do that. Copy and paste first, replace the square root 396 with 6 root 11. Here, square root 11 over 9 is just square root 11, then divide by square root 9. Okay? Okay. Rationalize the denominator. Or actually, before we do that, since we are dividing, we should combine into a single fraction first, so it's easier. Do you know what is KCF?
No.
Keep the first fraction, divide, change into times, C for change, F for flip, 5 over 4. Divide, then you have to change to times and you flip the fraction. This one you know, right?
Okay.
So same thing over here, we got divide. So we need to flip this entire fraction. So we have to first express this entire thing as a fraction first. Okay, so how can we add them together? Make denominator the same, right? How? How do you convert this from root 9 to 9? Multiply top and bottom by? Oh yeah, correct. Yes, you did it already. Square root 9. Then of course square root 9 is just a 3 actually, so you don't really need to rationalize. Yes, okay, let's just cancel this off, write down a 3 and then times 3 times 3. So all together we will get, if I can just combine them, 3 root 11 over 9. Then you combine them together. 6 root 11 minus 3 root 11 left with 3 root 11. So I'll just write down straight away. Can? So far, okay?
Yeah.
Yeah, okay, good. Then therefore we can flip the fraction now. So it's 1 over 2 minus square root 11 multiplied by 9 on top. Oh, wait, actually the 3 and 9 can cancel off first. Let's just simplify as much as you can before we continue. So it's just square root 11 over 3. Then we flip the fraction, so times 3 over square root 11. Is that okay?
Yeah.
Oh, first one don't need equal. Equal, and then this one need to simplify. So let's just multiply out first. So 3 times 1 is 3, 2 root 11 minus 11. Then you have to multiply by what?
Conjugate.
Yeah, so 2 root 11 plus 11, 2 root 11 plus 11. Minus change into a plus. Then you get a square minus b square. No space. Okay, I'll squeeze it here. So it's just 3 times, sorry, my 11 looks like a 4. 6 root 11 plus 33. This one will become 2 root 11 square minus 11 square, which is 4 times 11 minus 121. Let's calculate that. 4 times 11 minus 121 is a negative 77. Can?
Yep.
Okay, good. Then we can split it up. So you get 6 over negative 77 times square root 11 plus 33 over negative 77. I'll just swap them around now. So I will get this guy. Then 33 over 77, I can cancel off 11. So I'll be left with 3 over 7. Oh, so therefore A is negative 3 over 7. B is equals to negative 6 over 77. Can?
Okay.
Yeah, I hope the answer is correct. Yeah, okay. Can simplify. Yes. All right. It's okay to leave your answer in this format. This format is also okay. Can?
Mm.
Either format is fine. They never specify. Okay, next question. Okay, area of rectangle, very common question. Okay, so you have an area of a rectangle given by 3 root 3 plus 5 root 2. You know the length of the rectangle is 2 root 3 plus 3 root 2. Area equals 3 root 3 plus 5 root 2. So what is the breadth? We know area is equal to length times breadth. So how do you find breadth?
Divide.
Yep, so you just have to take area divided by the length. Then how do you simplify into this format? You need to use you need to rationalize the denominator. So times top and bottom by the conjugate. So what's the conjugate?
2 3 minus 3 root 2.
Oh, by the way, I should also mention what we are doing this procedure is called rationalizing the denominator. Denominator bottom, not the top. Don't get confused. Okay, denominator, what do you get? A square minus B square. So 2 root 3 square minus 3 root 2 square. I'll just write it in first. Then the other one can multiply already. 3 root 3 times 2 root 3. 3 times 2 is 6. Root 3 is 3. 6 times 3 is 18. This part okay?
Yeah.
Okay, next one. 3 root 3 times minus 3 root 2. I'll get a negative 9 times root 6. Because 3 times 2 is 6. Okay, next one. Positive times positive gives me positive. 5 times 2 is 10. So plus 10. Then root 2 times root 3, root 6. Next one, positive times negative gives me negative. 3 times 5 is negative 15. Root 2 times root 2 is 2. So 15 times 2. Simplify, we will get 30. Is that okay? Is this okay? Can, good. Can, let's move on. So now you get hold on a second. Okay. There's a fly. Oh my goodness. Sorry. Okay, let's simplify the numerator. What do we get? 18 minus 30.
Wait, what? 18 minus 30. Minus 12.
Then minus 9 root 6 plus 10 root 6.
Just root 6.
Good. Then denominator.
12 minus 18.
Yes, correct. Good. Yeah. Okay. Then you'll get a negative 6 at the bottom. So negative 12 plus root 6 over negative 6. Simplify, we get negative 12 over negative 6 plus root 6 over negative 6. Simplify a bit more, we get 2 minus away 1 over 6 root 6. Can? Okay, good. Can, that's it. Yeah, that's all. Okay, question 12 done. Move on. Question 13, skip. Question 14. Okay, this one. Let me copy it first. let's take a look at question 14. You want to simplify this. There's a part B. We start with a part B. 2 root 5 minus away 3 root 3 divide by root 3 minus 3 root 5. There is no part A. How? Again, you just need to rationalize. So which one do you rationalize again? The numerator or denominator?
Denominator.
Denominator. Okay, good. So what is it?
Root
conjugate?
3 plus 3 root 5.
Bottom only?
Top also.
The top as well. Okay, good. So now multiply out everything. You get the drill already, huh? So a square minus b square at the bottom first. Then numerator. This times this, 2 root 15. This times this, 2 times 3 is 6. 6 times root 5 becomes 6 times 5, 30. Oops. Next one, negative times positive gives me a negative. 3 times 3 root 3 times root 3. Root 3 becomes a 3. 3 times 3 is 9. Minus 9. Next one, minus 3 root 3 multiplied by 3 root 5. You get a negative first. 3 times 3 is 9. Root 3 times root 5, root 15. Is this okay?
Okay.
Can, good. Then you have 2 copies of root 15 minus 9 copies of root 15. That's just negative 7 copies of root 15. I'm going to write it on the right side because I like my square root on the right side. Then 30 minus 9, it becomes a 21. Can? Then denominator, root 3 square, you get a 3. Okay, I'll just write it at the bottom here, 3. Minus away root 3 root 5 square. So 3 square times root 5 square, which is 9 times root 5 square is 5. 9 times 5, 45. Is that okay?
Okay.
Simplify, you get a negative 42. 21 on top, minus 7 root 15. Numerator is just 21 minus 7 root 15. Simplify, you get 21 over negative 42, negative 7 root 15 over negative 42. You get negative 1 over 2 plus 7 over 42. That's 1 over 6 times root 15.
Okay.
Okay, good. That's part B. Let's move on to part C. Part C here, what you need to know is that the numbers are very big. Okay, whenever you see that the numbers underneath the square root is quite big, you should try and simplify them first. So 75, what is it equal to? Isn't it just 25 times 3?
Yeah.
Square root. What's square root 25?
5 root
And
3.
then root 3. Okay, good. Next, square root 80. Isn't it just 16 times 5?
Mm.
Then you can square root both of them. Square root 16, you get a 4 with a root 5. Can?
Okay.
How about square root 27?
Root 9 times root 3.
Which
3
is?
root 3.
Exactly. Okay, how about root 12?
Root 3 times root 4. 2 root 3.
Very good. Okay, we can simplify it now. So this guy will just be equal to square root 75 is 5 root 3 minus 2 root 3, cannot simplify that, plus 7 root 5 also cannot simplify, so just copy. Minus root 80 is 4 root 5 divided by root 27 is 3 root 3 minus away root 12 is 2 root 3. Simplify, denominator 3 copies, 3 apple minus 2 apples, you're left with 1 apple, just a root 3. Numerator 5 minus 2 is a 3 copies of root 3. Then 7 copies minus 4 copies plus 3 copies of root 5. Let's see how what we need to do now is to rationalize the denominator, but there is a special way to do it for this question. Notice there's a common factor of 3 on both of them. at the numerator.
Yeah.
What's 3 over root 3?
3 over root 3 is
3 is just root 3 times root 3, right? You see that? 3 is root 3 times root 3. So you substitute. Then you cancel off common factor, left with a single root 3. So cancel off. The numerator becomes a root 3. Then we are left with a single 1 at the denominator. 1 is a rational number, so we are done with rationalizing denominator. So the answer is root 3 bracket root 3 plus 5. You can multiply in, then you get root 3 times root 3, which is 3, plus root 3 times root 15, which is root 15. 3 times 5. Can? Okay. Oh, okay, good. Then we move on. I hope it's getting easier, the square root questions. After doing so many. Okay, next one. Okay, Ken, 16, go. Do you want to try on your own?
okay.
Ken, go. Area of a rectangle. I'll give you a hint first. Draw area for you. The rectangle. 12 plus 6 over root 3. Take out paper and pen and try it on your own. Yeah. Length
okay.
is 3 plus root 12. And then later you can take a photo and send. I'm trying to find the width. So what's the first step? Width equals to?
Area divided by length.
Yeah, so it's 12 plus 6 over root 3 divided by the length. How come here got a nested fraction? A fraction inside a bigger fraction. How do you deal with it? Maybe I'll start you off with multiplying root 3 at the top and the bottom. So let's see what happens at the numerator. Root 3 times 12, root 3 times 6 over root 3. You will get a 12 root 3 plus 6, just 6, right? They will cancel off. Divided by 3 root 3 plus root 36. What's square root 36?
Square root 36. 6.
Exactly. So it's just a 6. Oh, okay. Before we even continue, before you start rationalizing the denominator, look at the fraction. Look at the coefficients. Any common factor?
Yeah, 3.
Yeah, right. Can factor out 3 first, before you start to multiply everything. Try to factor out, simplify as much as you can. Then the 3 cancel off. Then you continue. The numbers are now a lot smaller. When you're done, can take a photo and send me. And let me know when you send it. Shout into the microphone.
Okay.
Hi, oh, you sent it? Okay, let me check. All right, so you multiply root 3 minus 2 top and bottom. Okay, then you get 12, correct, minus 8 root 3, correct, plus 2 root 3, correct, minus 4, correct. Divide by root 3 square is 3, 2 square is 4, then minus, so it's a negative 1. Simplify numerator, 12 minus 4 is 8, divide by negative 1, negative 8, good. Minus 8 root 3 plus 2 root 3 is minus 6 root 3, divide by negative 1, positive 6 root 3, perfect, exactly. Correct. Can you hear me?
Yeah.
Okay, good. Okay, yeah, your answer is correct. Okay, if you can do that, then I think a bit no point to do the rest. Let me see if I can skip. Let me see if there's anything special about all these other questions. A little bit different. Okay, this one. Okay, 21, I'm gonna skip. Just skip this already. It's no point, you can do already. This one also skip. Skip. You can do as homework. This one I'll go through, this one I'll go through, this one I'll go through. Then later the rest I'll also go through. Okay, can. Let's go. Let me copy the question first. Is my shared screen still there?
Uh-huh.
Okay, good. Question 17, let's go. So this one, you want to try? Or should I just go through?
What is this?
Okay, I just go through. So here you got a pair of brackets, then 1 plus a fraction multiplied by 1 plus square root 2. The advice that I gave you was to lump this 1 plus square root 2 as one thing, distribute into each of them. So let's just copy down the question first before I continue. The trick here is to leave the a plus b root 2 alone, focus on the left-hand side first. Eventually, rewrite it as something plus something multiplied by square root 2. Then you can conclude what's your a and what's your b. So how do we do it? Let's see. 1 plus root 2 multiplied by 1. What do you get? 1 plus root 2 plus 1 plus root 2 multiplied by 1 over 1 minus root 2. You'll get 1 plus root 2 on the numerator, divide by 1 minus root 2. Equals a plus b root 2, leave it alone. Never mind. Okay, maybe just to make it neater, I'll write my a plus b root 2 on the left-hand side like this. And then the expression on the right-hand side. Then my simplified version on the bottom like this. So I can leave a blank space. Can then we can start to simplify. 1 plus square root 2 can't do anything to it, leave it alone, copy paste. Plus this one we can do something. Multiply top and bottom by conjugate. Conjugate of numerator or denominator? Which one? Conjugate of?
Denominator.
So what is it? 1?
1 plus 2. I mean 1
Square
plus root 2.
Okay, good. 1 plus root 2. Then you can multiply. 1 plus root 2, 1 plus root 2. It's just a perfect square. 1 square plus 2ab, 2 times 1 times root 2 plus root 2 square, which is 2. Divide by a square minus b square. 1 minus 2. 1 plus root 2. Add on 1 minus 2 is negative 1. 1 square is 1. 1 plus 2 is 3. 3 plus 2 root 2. Simplify, we will get negative 3, negative 2 root 2. 1 plus root 2 in front. Just copy paste. Anything else to simplify? Yes, 1 minus 3, negative 2. Plus 1 copy of root 2 minus 2 copies of root 2, negative 1 copy of root 2. Therefore, a equals to negative 2. B equals to? Tell me.
B equals to minus 1.
Yeah, minus 1, correct. Here there's an invisible 1. Okay, must know. Invisible 1, nobody will write the 1. But you need to know there's a 1 there. Okay, minus 1 times. I'll just write it down for you. Only because you're a beginner, then I'll write this down. Usually, nobody ever writes down the 1. Can understand? Can? Okay,
Yep.
moving on. Next question. Oh yeah, I'm curious. How come you don't want to do your work on a iPad? Then you can just send me the PDF.
Uh, I actually really don't know how you like write so neat. Like like
Huh?
the way I write is like very big. Like
Use line paper. What?
I actually like I don't know. Yeah.
Okay, you prefer paper and pen. Can sure, go ahead. Your handwriting is super neat. So it's
Oh,
okay.
I've
Yeah,
heard
just
that that's like not a good thing.
very slow.
Yeah, I've heard like I don't know. I heard like people with messy handwriting.
Yeah, it's okay. Fine. Your handwriting neat will go very far. Okay. My handwriting not neat. I'll use a computer to help me. Okay, Ken. So let's take a look at this question. Without using a calculator, you want to simplify this fraction here. This guy here, it was my hint to you. It was a hint. It was part of the hint. Okay. So the trick here is now notice that the denominator here has a power 4. So if we want to rationalize the denominator, typically there's no power. So what we need to do you get is to rationalize the insides. So what is inside? It's 1 plus root 2. If you rationalize it, it means you want to multiply by 1 minus root 2. You wish to multiply the 1 plus root 2 with 1 minus root 2. So you want them to have an interaction. However, you can think of this bracket power 4 as like a bouncer, like a guard guarding a house. Then in order for this 1 minus root 2 to gain entry, he has to go through this power 4. So that means you must also equip yourself with a power 4. Does it make sense?
Yeah.
Because in order for two numbers to be multiplied together, here what we have is a power 4. We are multiplying by a b power 4. After you multiply them, because they have the same power, you can factor out the power. Then the a times b can be together. The b can get to go inside the a. Okay? Understand?
Okay.
So if you
Yep.
multiply 1 minus root 2 and power 4 at the bottom, you also need to multiply by the same thing at the top. Now we simplify. Root 2 plus 3, power 4. That seems familiar. Binomial expansion. 1 power 4 plus. I'll just draw the triangle because I am lazy to write down 1, 4 choose 0, 4 choose 1, 4 choose 2. Get the answer straight away. That's my 4 choose 0, 1, 2, 3, and 4. Also 1, 4, 6, 4, 1. Yeah, so 1 power 4 plus 4 times 1 power 3 times root 2 power 1 plus 6 times 1 power 2 times root 2 power 2 plus I'm running out of space. 6 times 1 power 1 times root 2 power 3 and I really ran out of space. Okay, move it. Plus the last one is 1, 4, 6. Oh, second last one. 4 times. Did I miscount? Let me see. 1, 4, 6. Yes, I miscounted. This should be a 4. Then there should be a 1 times 1 power 0 times root 2 power 4. Can? Can okay, then power 4, then the denominator will be 1 plus root 2 times 1 minus root 2. Okay, so we can simplify the numerator. Oh. Yeah, so there's a root 2, there's a square, there's a root 3, there's a root power 4. Okay, I'll just simplify everything. So 4 times 1 power 4 is just 1. Then here, 4 times 1 power 3 is just 4. Then multiply by root 2. Here you got 6 times 1 square is just a 6. I can throw away the 1 square. Then root 2 square is just a 2. So 6 times 2. Or is it just 2? 6 times 2 is 12.
12.
Good. So you have a 12 here. Then 4 times 1 is just a 4. Root 2 cube. This one have to be a bit careful. Root 2 to the power of 3 means root 2 power 2 times root 2 power 1. Root 2 power 2 means square. You get a 2 times root 2. So this is just, so root 2 cube is just 2 root 2. But we actually have a times 4 in front. Right? Okay, I better not write it down. So therefore, 4 times root 2 cubed is really just 4 times 2 root 2, which is 8 root 2. Can? So this is equals to 8 root 2. Then this one, 1 power 0, anything power 0 is?
1 power 0 is just 1.
1, yes. Okay, then 1 times 1 is still 1, 1 times 1 is still 1. Then root 2 power 4 is what? Root 2 square, then square again. Root 2 square is 2. 2 square is 4.
16.
Yeah.
Wait, yeah.
4. It's just a 4. Okay, or you can think of it as root 2 is 2 power half, then power 4. 4 times half is 2. So it's 2 power 2, which is 4, not 16. Okay. Simplify a bit more. Wow. The denominator over here, 1a plus b, a minus b, what does it become?
A square minus b square.
1 square minus root 2 square. Okay, I'm just going to write it at the side. Then 1 square minus root 2 square, simplify, you get 1 minus 2, negative 1. What's negative 1 to the power of 4?
Is 1.
Yes, it's just 1. So if you divide by 1, do you need to do anything?
No.
Don't need. Then you can just drop the denominator already. Okay. Can understand, huh?
Yeah.
Okay, maybe I should write a bit more. Negative 1 to the power of 4 is just negative 1 to the power of 2, then square it. When you got a square inside, it becomes a positive already. Then 1 power anything is just 1. In general, if you got if it's negative 1 to the power of an even number, like let's say 100, you can always rewrite it as negative 1 power 2, because 100 can divide by 2. It's 2 times 50. I can rewrite it like this. What's negative 1 square? It's just positive 1. So it's positive 1 to the power of 50. 1 times 1 times 1 times 1, 50 times. You just get a 1. Oh? As long as you have an even power, it will always be positive 1. In general, negative 1 to the power of even is a positive 1. Negative 1 to the power of odd is equals to negative 1. Is this okay?
Yes.
Can Okay, good. So that's why 4 is an even number. That's why you get positive 1. Divide by positive 1, you can throw away. Then the numerator now can be simplified. Let's just collect like terms here. I'll highlight it. 1, 12, 4. What do you get? 17. 4, 8. You get a 12 root 2. Is this okay?
Yeah.
Then you multiply out. So this, that. Let's just do it. 17 root 2. Root 2 times 17, 17 root 2. Root 2 times 12 root 2 is 24. Then 3 times 17 is 30, 21, 51. 3 times 12 is 36. Don't forget the root 2. Okay, good. Then we can combine. What else we have? We got 17 root 2 plus 36 root 2. 36 plus 17, that's a 40, 53 root 2. And then 24, 51 is 75. Right? Okay, make it neater. Write the 75 in front and the plus 53 root 2 at the back. And then we are done. Can?
Okay.
I think I hope I calculated correctly. Okay, should be correct. Let's just check with the answer. It's wrong. Oh no. Let me see. I made a mistake somewhere. What could it be? Where could the mistake be? I see it already. Yes. Sorry. Here, whenever you got binomial expansion, there's a minus in front. You have to rewrite as what? 1 plus negative root 2. Then you power 4. So A is 1 and B is negative root 2. Here I assume my B is a root 2, which is wrong. What should it actually be? It should be your negative root 2. Does that make sense?
Oh, okay.
Sorry, I forgot that. Yeah, so there's an extra minus sign here. Okay, wait. This should be a minus. This one even, so it become positive. -1 to the power of even number, so it's still positive. Don't need to worry. But the odd ones are the ones I have to worry about. So this plus I change to a minus. Okay. Is that all? This one even, so it become positive. Power still positive, so I don't have to worry. It's just the odd powers that I have to worry about. Okay. Then there should be a plus, minus, plus, minus, plus pattern. Every time you got a minus here, usually not always you have a alternating pattern in terms of the sign. Plus, minus, plus, minus, plus. Is that okay?
Okay.
Okay, okay, moving on. Yeah, this one all wrong already. Okay, at least the denominator is still okay. At least the denominator is still okay. Let's just simplify this one. So 1, 12, 4. Oh, luckily still the same, 17. How about the 4 root 2 and 8 root 2? You get minus 12 root 2. Then you multiply out. Let's see if we get what we will get. 17 root 2 minus 12 times root 2 is 2, so minus 24. So 3 times 17 is 30 plus 21, 51. 3 times 12 is 36, so minus 36 root 2. Simplify. 17 minus 36 is the same as 36 minus root 2 with an extra minus sign. 36 minus 17 is the same as 36 minus 16 minus 1, which is 20 minus 1, which is 19 root 2. Minus 24 plus 51. 51 minus 24 is the same as 50 minus 23. 50 minus 20 minus 3. 30 minus 3. 27. Of course, you can just use a calculator for this. Okay, good. Yes, it's correct. Let's double check with the answer key. 27 minus 19 root 2. Is it the same?
Mm-hmm.
Yes, the order doesn't matter. Plus, minus, you can swap the order. So this is okay. Yay, great. 18 done. Let's move on. This is question 19. Let me get rid of the extra markings. Okay, let's see. So you have a triangle ABC. Thankfully, its angle is 90 degrees, so we don't need to resort to sine rule, cosine rule. AB is 1 over 3 minus square root 5 cm. BC is 1 over 3 plus square root 5 cm. Then without the use of a calculator, you want to find the length of AC, leaving your answer in third form. So what rule can we use here? Right angle triangle.
Pythagoras.
Pythagoras theorem tells you that AC square equals to AB square plus BC square. So let's just find out the squared version first before we continue finding what is AC. So remember, this is AC square. We are trying to get AC square first. Later, the last step, we need to take what? Take the
square root.
Square root. Okay, remember, help me to remember in case I forget. Remember, we need to take square root later. Okay, let's find out what's AC square first. So it's AB, which is 1 over 3 minus root 5 square plus, yeah, I should write this down. Square root later, exclamation mark. BC is 1 over 3 plus root 5 square. Okay, zoom in. Let's see how to simplify this. 1 becomes 1 square. 3 minus root 5 becomes 3 minus root 5 square. Same thing with the other guy. Of course, 1 square is just 1. Okay, I'll just get rid of the square. Then we simplify this. So 3 square minus 2 times 3 times root 5 plus root 5 square. A square minus 2ab plus b square. Same thing with the other guy. You can simplify straight away, but I'm just doing it step by step in case I make any careless mistakes. 3 square is 9. Root 5 is 5. Root 5 square is 5. 9 plus 5 is 14. Minus 2 times 3 is 6. Root 5. Add on. 3 square is 9. Root 5 square is 5. Same thing. You still get 14. But here it becomes plus 6 root 5. And it makes sense that you see what happens. They are what? Conjugate surds, right?
Yeah.
Why is that the case? Because look over here. 3 minus root 5, 3 plus root 5. They are already conjugate surds. After you square them, you still get conjugate surds. I think that's quite a natural thing to conclude. You can prove it using math. If you watch the video, how to prove things. Can do proof by contradiction or something. But no need. It's not important. Just a side note only. Okay, then now you want to add them together. What do you do? Can I just skip a step and just combine into a single fraction? You know, right? You need to multiply top and bottom by the conjugate.
Yeah.
Oh wait, actually, there's a common factor of 2. How I can rewrite as 2, then 7 minus 3 root 5. So the number will be smaller. But there's no point to doing that. I think the numbers are not that terrible. I can deal with it. So I'll just multiply by its conjugate straight away. Here it will be the minus version. You know how to find the conjugate, right? 14 minus 6 root 5. Don't need to explain now.
Yeah.
Okay, yeah. Then denominator will be 14 square minus away 6 root 5 square. Then numerator will be this guy here, 14 plus 6. Oh my goodness. What did I do? Okay, 14 plus 6 root 5 times 1. And then you add on 14 minus 6 root 5. Because 1 times, then you don't need to do anything. 1 times this, just left with the original. 1 times of that, left with that. Okay, simplify the denominator. I'll just use a calculator straight away. 14 square minus open bracket 6 root 5 close the bracket square. I will get a 16. Is that clear? How I got the 16? Can Then 14 plus 14, 28. 6 root 5 minus 6 root 5. Cancel. Okay. 28 over 16. Wow, so simple. Then you can just type in the calculator or use mental sums. 7 over 4. That's your answer. Yeah, is that our answer? Forget. Yeah, younger than me, you must remember.
Square root.
Square root later. We found AC square root. They're asking for AC. So last step is to take the square root. Okay, so now we want to find the AC, which is the square root of 7 over 4, which is square root 7 over square root 4. Nothing but square root 7 over 2. Answer. Okay?
Okay.
Okay, here when they ask you leave your answer in surd form, it means that they expect an exact answer. Exact answer. This is quite common. From after you learn surds, right? You can no longer use your calculator and round off to 3SF anymore. You have to get the exact answer. You have to go through this procedure. Okay? More long-winded, but you will get an exact answer. Okay?
Okay.
It's like maybe I'll give a quick example. Like let's say 1, 1, then what's the length here? If it's 1, 1, what kind of triangle do we call this?
Isosceles.
I so silly. I so silly. I'm isosceles triangle. Okay. So that will be a 45 and 45. Correct or not?
Yeah.
90, 180 minus 90, you get 90, then divide by 2, 45, 45. What's the final length here in exact terms? It will simply be, let's call it x. X square equals to 1 square plus 1 square. Correct? What's 1 square plus 1 square? It's 2. So x equals to plus minus square root 2. But you don't need minus because x is a length. So just positive square root 2. That's the exact answer. Okay?
Okay.
So what's sine of 45 degrees? Can you remember?
No. Sine 45 opposite over height.
Which is, in this
1
case?
over square root 2.
By the way, do you know that sine 45 degrees is a value and it will stay the same regardless of what size is the triangle? So here I use 1, 1. If I double it, will sine 45 change? Will sine 45 change? 45 here, 45 here. If this is now
No.
2, then this is 2 root 2.
No, cause
No,
ratio.
of course. It's a ratio. They'll cancel off. And anyways, you can also type in the calculator sine 45. They'll give you a half every time. So yeah, this is what we call the exact value of sine 45 degrees. It's a topic in AMAX. Later, I'll talk about it in a later chapter. Here is just a preview. Okay, certs are required as a prerequisite before you can learn trigonometry at AMAX. Okay?
Okay.
Okay, now another triangle. Okay, I'll just since I talked about 45 already, I'll just talk about another triangle. A triangle with all sides equal. What do you call that?
Equilateral.
Equilateral. What's the angle here? Equilateral, all sides equal, all angles also equal. So what's
60.
the angle? 60 degrees, 180 over 3. Then now we're going to cut it in half, chop it in half. This is what we call the perpendicular bisector. Doesn't it look like a circle? Remember? Perpendicular bisector of a chord. This is a chord of a circle. If you remember your Emacs. Yeah, but anyways, just chop it in half. What do you get? We're going to force this length to be a 2 for convenience. We're going to force each of the lengths to be a 2. Then what happens if you chop in half? What's the remaining length here?
1.
It's a 1. Okay, good. So I'll get rid of that 2 there. So it's 1, 1. If this is length 2, this is length 1, what's the remaining length here? It's quite wide. Pythagoras, what is it?
Root.
I'll do it step by step. 2 hypotenuse square
Square
equals
minus 1. 4 minus 4. Root 3.
Root 3, exactly. So that's the exact value, root 3. If this is a perpendicular bisector, what's the angle over here? Perpendicular.
90.
90 degrees, of course. Then what's the remaining angle there?
30.
30 degrees. Now you memorize this triangle. Dung, dung, dung. 1, 2, square root 3. 1, 2, square root 3. 30, 60, 90. 1, 2, square root 3. 30, 60, 90. 1, 2, square root 3. Okay. Anyways, what is sine of 30 degrees now?
Sine of 30 degrees is 1 over 2.
1 over 2. Good. What? No.
I mean,
Oh, wait. Actually, correct. Sorry, I'm wrong. You're correct. How about cosine of 60 degrees?
cosine of 60 degrees is 1 over 2.
It's the same. What a coincidence. How about, let's try sine of 60 degrees?
Sine of 60 degrees is root 3 over 2.
How about cosine 60 degree? No, we already did that. How about cosine 30 degrees?
Cosine 30 degrees is root 3 over 2.
They're the same again. What a coincidence. No, it's not a coincidence. Here's a general rule for you to remember. Whenever you got two angles, alpha plus beta. Okay, sorry, I don't introduce this. I'll just use A and B. Whenever you got two angles, A plus B adds up to 90 degrees. Sine of A will be equals to cosine of B. Okay?
Okay.
Doesn't matter. So like, for example, sine of 1 degrees is actually equals to cosine of 89 degrees. You can check with a calculator. Why is this true? Draw a right angled triangle, call this theta. This will become 90 minus theta. Or in other words, you can call this angle A and this angle B. Does it make sense? A plus B is 90 degrees.
Okay.
Can, right? If it's 90 here, 180 minus 90 gives you 90 degrees, which is the sum of the other remaining angles. So what? Let's call this ABC. Maybe I don't call it ABC, I call it XYZ. What is the sine of A?
Sine A equals cosine.
In terms of the fraction, it will be. Sorry, are you writing something? I didn't see.
No.
Oh, okay, good. Opposite over hypotenuse, right? So
Y over Z.
y over z. Then how about cosine of b?
Y over Z.
Y over z as well. What a coincidence. So therefore, they are the same for every single length. I said x, y, z. I didn't say any other length. Right? It could be a 3, could be a 4, could be a 5, could be a 5, a 12, a 13, anything. 7, 24, 25, 8, 15, 17. It doesn't matter. The fraction ratio will always be the same. Okay? That's therefore proven. Please remember this rule. It's called the complementary identity. There's still two more you need to know. I think I'll stop for now. We'll talk about it if we go into trigonometry, when we get to trigonometry. Okay, quite a lot of things to cover. Complementary identities. There's still two more. There's two more. Formula. What's the plural of formula? There's two more formula. Okay. Can. That's a side note. Okay, so you have found out the exact values of sine 30, cosine 60, sine 30, cosine 30, sine 60, cosine 60. You also found out the exact value of sine 45, and let's just complete the story. How about cosine 45 degrees?
Cosine 45 degrees equals to 1 over root 2.
Okay, it's the same as well. Reason being, you are following this rule. The sine A equals to cosine B. A equals 45, cosine equals 90 minus 45, which is 45. Okay?
Okay.
Yeah. So that's why they're the same. It's not a coincidence. You can prove it. Okay, that was a distraction. So we have found out the exact length of a right angled triangle, which is useful in trigonometry. Okay, it is required in trigonometry for you to find out the exact value of sine 30 of the sine 30, sine 45, cosine 45. Let me just one more extra thing. It's also from trigo. Also from trigo. It's called the exact values. Exact trigo values. You must memorize this table eventually. Theta, okay, you're not going for exam, so it's fine. But AMAX student, they had to do this. 30, 45, and 60. You draw a table, and then you're going to find out what is the sine of theta, cosine of theta, and eventually tangent of theta. If you remember the formula for tangent, it's sine over cosine. Do you recall this?
Okay.
Yes, then you need to get the exact values. There's a certain pattern. I'll leave that to you. I already talked about the first 6. The bottom 3, you can work it out yourself. So homework. Right? Homework. Find out those values to find. Okay, you can Google and you'll find it out, but you can try on your own before you Google or when I talk about it. Okay, that is this question. AC equals square root 7 over 2. Done already. Let's move on to the next question. Ken? Okay, move on. Next. Okay, crop this, move down. Oh, wait. No. Okay, then that's it for this worksheet already. The rest will be, I don't want to go through already. You can solve already. No point in going through. 20 and 21. Oh, wait. No. Not done with the worksheet. Still got those questions that I skipped. Right. Sorry. Forgot. Let's go back. So now question 2. How do you solve for x in this kind of equation where there are square roots involved? Let me start a new page first before I continue talking. How? Let's copy down the equation first. Square root 3 minus 2x minus away square root x plus 2 equals to square root of 3x minus 1. How? What do you need to do? What's the opposite of square root?
Square.
Square. And why do I want to deal with the square? Because I see my x is trapped underneath the square root. To rescue my x from the clutches of the square root, I need to take a square so that I can slay the demon or something. Get rid of the square root. Okay? So that's why you want to square. And when you square, you should square both sides of an equation. So here's how you do it. Bracket, square. bracket, bracket, square. Coincidentally, this part here, when there is only a single square root, they will cancel each other off neatly to give you a 3x minus 1. Agree?
Okay.
Good. Then we can now deal with the left-hand side. A minus b power 2. A square minus 2ab plus b square. That's what we're going to do. So a square, I hope you realize that they will just cancel off with the square root. Okay, I'll just write it down for now. A square minus 2 times a multiplied by b, add on b square. No space. Let me move it to the side. B square is square root x plus 2 square. What happens to your square and square root? They will cancel off. You're left with 3 minus 2x here, x plus 2 there. In the middle, copy and paste this guy. Minus 2 times square root, square root. Okay? So far, okay?
Okay.
Then, still got a problem. Do you think we can solve for x already? Just make x the subject. Like factorize, factorize. Can we do that? Can we?
How?
What was the problem originally? The problem is that the x is trapped inside the square root. Okay, it's trapped inside the square root. Here, do you still see an x underneath a square root?
Yeah.
Yes, over here and here, right? So that means we cannot continue yet. What do we need to do to make sure these x can get rid of the square root, can escape from the square root? Same trick as before. Just now we square both sides. We also need to square both sides. But you need to make sure that this fella here is isolated on its own, so that the moment we square it, it will cancel off with the square root. So that means we need to make this guy the subject. Okay? So I'm gonna make this guy the subject. Are we clear on that? You're trying to rescue the x from the collapsed building, the square root. Then you need to square it. So you need to isolate it on its own. So bring everything that's not underneath the square root to safety. Escort them away from the collapsed building. Bring them away to safety. Bring them away to the right-hand side. So we're gonna make this guy the subject. Equals to 3x minus 1. Then 3 minus 2x bring over, become minus 3 plus 2x. This one, x plus 2 bring over, minus x minus 2. Clear so far?
Okay.
Simplify the right-hand side. So let's see, 3x plus 2x minus 1x. 3 plus 2 is 5, 5 minus 1 is 4, 4x. Minus 1 minus 3, minus 4. Add as a minus away another 2, get minus 6. Clear so far? Okay, good. Now we have the left-hand side. Let's see, just copy down again to make it neat. What do you realize? You realize there's a square root times a square root. What do you have when you have square root a times square root b?
Can
just equal to?
Square root a times b.
Okay, good. But let's just not multiply it first. We just simplify it into 3 minus 2x times x plus 2 first. Don't expand. Very, very distracting if you expand. Okay? This part okay so far? Now what we're going to do is, again, just now when we had a single square root on its own, we square both sides. We managed to rescue the x that's inside. So here you got a square root. What do you think you want to do? Again, both sides you want to square. Make sure you square the entire equation. So even though you see like two separate terms, when you square both sides, is it equal to 4x squared minus 6 squared? No. Make sure you got that. So you must square the entire thing. You cannot square individually. Okay? Can Good. Let's move on. So now, whenever you got minus 2, which is just a factor, and in front of the square root, it's actually a multiplication going on. Negative 2 multiplied by a square root, whatever. So a times b square means what? Means a square times b square. What happens when you have a square and square root?
Cancel
off, but make sure you got a negative 2 square in front. Okay, so that's what we're going to do. Negative 2, oops, let me get my black pen. Negative 2 square. Then square root whatever, don't expand yet. Later then expand. Square. What happens? We simplify. We get our 4 square root square cancel off. We're left with whatever is underneath the square root. Copy and paste. Then the right hand side, It's not 4x squared minus 6 squared. It's also not, even if you put a bracket there, it's still wrong. You actually need to do it term by term. So let me just do something extra. 4x minus 6, I can factor out a 2. So I get 2x minus 3. Then I square. Does that make sense?
Okay.
So it becomes a 4 multiplied by 2x squared. So 4x. So 2x minus 3 bracket square. So we get 4x squared minus 2 times 2 times 3 is 12x plus 3 squared is 9. Why did I want to do that? Because I see a 4, I see a 4. What can I do?
Cancel.
Cancel off. Just to be neater, I'll copy and paste it again. Make sure it stays on the same horizontal line. Then I neatly cancel them off. What am I left with? This time, you got a quadratic. Right-hand side, also quadratic. Oops, sorry. Quadratic. And just expand everything. Okay? Expand everything. Now you expand. I think it's safe to expand. Once you're free from the collapsed building already, then you play around. While you're still trapped inside, don't play around too much. If not, you accidentally leave an arm behind, leave a leg behind when you try to escape. Then no good. Okay? So yeah, let's expand it. So 3 times x, 3 times 2 get 6, minus 2x times x, minus 2x squared, minus 2x times 2 get minus 4x. Did I do something wrongly? Yes, I left out a square here. All right, I left out a square here. Is it correct now?
Okay.
Can good. Continue. We get the right hand side to be nothing lah. Just copy paste. 4x squared minus 12x plus 9. Okay, good. So we continue. How to continue? Bring everything. You realize what kind of equation is this?
Quadratic.
Quadratic equation. So we are gonna make everything equals to 0 on the right side. So let's see. Maybe I'll leave my 4x squared minus 12x alone, plus 9 alone. Then everything I bring to the other side. Then leave behind a 0. But then I put my 0 on the right side. So let's see. 3x become minus 3x. 6 become minus 6. Minus 2x squared become plus 2x squared. Minus 4x become plus 4x. Is this okay so far?
Okay.
Can Good. Then we combine like terms. X squared with x squared, 6x squared. Minus 12x with minus 3x and 4x. You get minus 12 minus 3 minus 15 plus 4 is minus 11x. Next one, plus 9 minus 6. You get plus 3 equals 0. How to solve? Quadratic equation. Use calculator. 6 minus 11, 3. I get x equals to 3 over 2 or x equals to 1 over 3. Finally, we are done. Or are we? Are we done? Yes, of course.
Yeah.
Got x already. Why would we have to continue? Is there anything else we still need to check? Here, unfortunately, it is a square root equation. Yes, you do. You need to check something. This is something called the domain of a function.
Or check whether need a reject.
Yes, correct.
Oh my god.
Not done yet. So now the problem is that square root underneath only can have 0 or bigger numbers, positive or 0 numbers. Cannot have negative. So we need to check whether we will get negative or not over here. So let's see. Here, there's a problem. Let's take a look. There's a 3 minus 2x.
Reject.
We need to check.
Reject 3 over 2.
Very fast. Okay. Wait. Check. Okay, I'll just put check and check. 3 minus 2x is 3 minus 2 times 3 over 2, which is 3 minus 2 and 2 cancel off. You're left with 3 minus 3, which is 0. Oh, still safe. 0 still can. 0 still can. Then you can check with the rest. X plus 2 as well. Okay, no space. X plus 2 is just 3 over 2 plus 2. This is obviously more than 0, so still safe. Then the next one, underneath the square root is a 3x minus 1. You have to check 3 times 3 over 2 minus 1. Also more than 0, I think. Yeah, so safe. So therefore, x equal 3 over 2 is acceptable as a solution. Acceptable. Then you'll do the same thing with the other check. Check. Wait, circle move. Okay. I want to check my 3 minus 2x, my x plus 2, and my 3x minus 1. So let's see, 3 minus 2 times 1 over 3. Let's calculate that. Okay, still more than 0. Okay. X plus 2, positive plus a 2, still more than 0. 3 times 1 over 3 minus 1. This one, maybe. what happens? 3 times 1 over 3 is 1. 1 minus 1 is 0. Can we have 0 underneath the square root?
Yeah.
Yes, you still can. So therefore, all 3 cases pass. That means that this is also acceptable. Pass is the correct answer. Sometimes, not in this example, maybe in a future example, the answer could be like -2. Then if you try to substitute in over here, let's say for example, 3 times -2 is -6. -1 is -7. So you get square root of -7. Does that work? Can we have square root of negative?
No.
Cannot. Then we have to reject. Can? This is how you solve Surt's equation. Easy?
Oh my god.
We got so now practice. Let's try another question. So the trick here is to square both sides 2 times. But the second time you have to be a bit more you have to be more careful. Okay, let's just do that. Wait a minute. Why did they reject one answer? 1/2. Oh, sorry. I realized. Okay. Sorry, this one 1/2. Let's share. You have to reject. Apologies. That's not the only way. Ayo, not done yet. This one I have to reject. Sorry, I see the mistake. You have to reject this. Do you know why?
Why?
Let's just check. Sorry, this I shouldn't be checking individual terms. I should also be checking left hand side and right hand side. Maybe that should be the faster way. Sorry, let me try again.
Or like you sub into everything.
But you check left hand side and right hand side. Yes, correct. So left hand side will be square root 3. Okay, we already figured out what's 3 minus 2x. So it's just a 0. Minus away. Oh yeah, by the way, when you're checking, you can just sub in the value directly. Don't need to show the working. It's quite obvious. X plus 2 is 3 over 2 plus 2. Let's just type in the calculator. 3 over 2 plus 2 is a 7 over 2. So this is just negative square root 7. Okay, we just use the decimal approximation already. Because this is getting a bit too long-winded. So negative 1.870. Okay, 08. How about the right-hand side? We have square root 3x minus 1. So 3 times 3. Okay, we already figured out 3x minus 1 is 3 times 3 over 2 minus 1, which is 7 over 2. Yes? Which is positive 1.8708. Do they equal to each other? Are they equal?
No.
No, one is negative, one is positive. Then what do we conclude? Since left hand side, okay, this equation don't need to copy down. I just copy down for reference only. Then you say since LHS is not equal to RHS, this concludes x equals to 3 over 2 rejected. Then sorry, this one I checked wrongly. I shouldn't be checking just okay. Checking underneath the square root is a shortcut. Sometimes it works, but in this case it doesn't. Because I was hoping that I will get a negative underneath the square root, then straight away I can reject. But here, what they want us to do is to check LHS and RHS. In this case, LHS will be what? Let's see. 3 minus 2x in this case is 3 minus 2 times 1 over 3, which is square root 7 over 3. Minus away x plus 2. So it's 1/3 plus 2 square root 7 over 3, which is equal to 0. Okay. Oh, battery, I should charge. Sorry, give me a moment to charge this. Okay, forgot to charge. Okay, yes, and left-hand side is 0. Let's check the right-hand side now. When x is equal to 1 over 3, we get square root of 3x minus 1 is a 0. Square root 0 is just a 0. Okay, so they are equal. LHS is equal to RHS. So therefore, x equals 1 over 3 except. I don't need to write except, but that's the answer. Only. Can?
Yeah.
Reject. Okay, let's try another practice question. maybe I only have time for one more, then yeah, then I'll just give you more certs practice questions and you can try the ones that I told you to skip. Okay, question 4, let's go. After this topic, it will be on, I'll move on to logarithms, I think. Yeah, see if we have time. Okay, solve the equation. Do you want to try on your own or should I go through?
Oh, I'm okay anyways.
Okay, you should try first. I think you should try.
Okay.
Or you tell me what to write, then I write for you.
Okay. Square.
Square both sides. What do I get?
A plus B square equals A square plus 2AB plus B square.
Okay, I assume you know that A is this guy and B is the guy.
Yeah.
So A square plus 2 times A times B plus B square equals to, what happens when you square and square root? Cancel. Square and square root cancel again.
Cancel.
Right hand side, same thing as well. You're left with 3x plus 7.
Okay.
I'll clean up for you. Wait, clean up by removing the square root now. Remove the square root. Okay, can continue. What do you do?
Okay. Then you still have this, so you move all this and this to here. So minus 3x minus x minus 2.
Correct. Yes, good. Okay. Okay, simplifying, I will get a minus x plus 5. Yes, correct. Then the right hand side is just left with the middle guy, the square roots. Okay, then how to continue?
Then you wanna get rid of this dude. So you can combine first.
Combine them.
Minus 1 x plus 1 like this.
With a 2 in front. Then what do you do next?
Square.
Square. Is it just square on the square root?
No. So 4.
Very good. Square the entire thing, and then you get a 4 times just square or square root, right? What happens to the square root? They will cancel. You're left with whatever is underneath. Like this, huh? Can? How about right hand side?
A square plus B square. I mean, A plus B square equals to A square plus 2AB plus B square.
But what is it exactly?
Okay.
Negative x bracket square becomes x square.
Plus 10. Wait, minus 10x. And then plus 25.
Perfect. Good. Okay, maybe this one, when you see minus in front, it's a bit distracting. So here's a suggestion. Whenever you see like
5 minus x.
Yes.
Okay.
No, even more. Here's what I usually do. I like my x to be 1x, positive 1x. So what I do here is I factor out a negative 1. Then I get x minus 5. Then the whole thing is squared. When you square the negative 1 times x minus 5, you get negative 1 square times x minus 5 square. What's negative 1 square? It's positive 1. So it simplifies into x minus 5 square. So this is just equal to x minus 5 square. Same, right? Same all? Okay, good. Yeah. All right, continue. What do we do next?
Yeah, you just expand this.
Just expand. Okay, I'll expand it for you. 3x squared minus 1 times x plus 1 times 3. So minus 1 plus 3 is plus 2x. Minus 1 times 1 is minus 1. Equals x squared minus 10x plus 25. Maybe if we are a bit faster, we can also times the 4 inside. 4 times 3, 12x squared. 4 times 2, 8x. 4 times negative 1, minus 4. Are we done? No, still need to bring everything over. Equals to 0 on the right side. So what is it? 12 minus 1? 11x squared. Next one, 8 minus 10 bring over plus 10.
Minus plus 18.
Yes. Minus 4 is still on the left. Plus 25 bring over become minus 25. Minus 4 minus 25 is?
Minus 4 minus 25 is minus 29.
Minus 29. Okay, then how to solve for x? Calculator.
Yeah.
7, 18, negative 29. You get x equals to 1 or x equals to negative 29 over 11. Are we done? Are we done?
No.
Except both. Cannot. Have to check for rejecting answer. There's one of them that has to be rejected. Negative 3. Wait. Hold on. Something wrong. What did I do wrongly? Oh my goodness. Sorry. I copied wrongly. This is a plus. Sorry. Plus. Oh my. Okay, let me just quickly redo this. I'm so sorry. This one should be a plus. I copied wrongly. Okay. Yeah, just redo. So this one will become 3x squared plus 1 plus 3 is a plus 4x, and then 1 times 1 is a positive 1. Okay, then equals to 3x equals to x squared minus 10x plus 25. Okay, then you expand 12x squared plus 16x plus 4 equals to x squared minus 10x plus 25. Bring everything to the right side. Right hand side is 0. 12 minus 1 is 11x squared. 16 minus 10 bring over become plus 10, so plus 26x. 4 minus away 25 is 25 minus 4 is 21, negative 21. Okay, then finally we got our quadratic. Type in the calculator 11, 26, and negative 21. I will get x equals 7 over 11 or x equals to negative 3. Let me double check with the answer key. Okay, correct. This one has negative 3 has to be rejected. How to check for rejection? We start off with the original equation. Okay, just a reminder. Then what do we do?
Sub in to the whole thing.
Let's just say check first. Check x equal to, maybe I should write check x equals 7 over 11. What do you have to check? Sub this into what? LHS. Make them separate. Don't just sub in the whole thing. You should write down LHS here. You know what LHS stands for, right?
Left hand side.
And right hand side, respectively. Okay. So so you should write down LHS first, then square root 3x plus 1. You can type in the calculator straight away. What's 3x plus 1? 3 times 7 over 11 plus 1. I think it's 32 over 11. And then you add on square root of, what is it?
It 18 over 11.
Okay, good. Then use a calculator to get the value.
Uh, 2.9848100029.
Okay, then how about the RHS? Let's check the RHS. Square root of 3x plus 7. So sub the x with 7 over 11. You get 3 times 7 over 11 plus 7. So it's 98 over 11.
The same value.
So we get the same value, then confirm equal already. Okay, I don't need to write so many decimals. Therefore, x equals to 7 over 11 is acceptable. Can you give me like a quick 30 seconds? I'll be back.
Okay.
Hold on. Then you can check. You can check what is your LHS here. What's your RHS here? You realize they are not equal, then you can reject. Give me 30 seconds. Hello, I am back.
Yeah, reject.
Yes, correct. So here is a shortcut. Because the x plus 1, yes, whenever you sub in x equal -3 minus 3 plus 1 is -2, you get square root -2. This is equals to √2 of I, where I is square root -1. That's in complex numbers. It's not in Amax. Okay, it's not in Amax. So yes, you can straight away reject. You don't even need to sub LHS and RHS in this special case. Okay, this one a heck. You don't even need. Square root x plus 1 will be equal to square root of -2, which is not an element of the set of all real numbers. What does that mean? Real numbers means all the numbers you know so far, not an element of. You remember this notation?
Okay.
Slash means not element of, means you're not real. So this means that there's no. So x is x. So this is rejected. Okay, then yeah, that's all for today already. Homework. What will it be? We already covered many questions. I'll tell you what are the ones that are left not solved. Then you can try it on your own. And I'll give you additional homework. Okay?
Oh, okay.
Yeah, then that's all for today.
Nice.
Yeah, 6, 7, 8, 10. You can try your search question. Just keep trying. I'll give you more on the other kind of search questions as well. Okay, that's all.
Okay.
Okay, bye-bye.
Okay, thank you.
Thank you. Bye-bye.